Good morning, good afternoon, and good evening, everyone. Today we'll see how software requirements and architecture are related. This is a Mongolian gur. A yurt or gur is a portable circular dwelling. Yurts have been the primary style of home in Central Asia, particularly Mongolia, for thousands of years. Most homes in Europe and US have this kind of rooftops, which are slanted. They look nice, but there is also a purpose. As we know from our childhood, and unfortunately, very few of us had the opportunity to witness it, this is igloo. Why are the region specific? What happens if I have an igloo next to my house in India? And why can't an igloo be made with wood? We know it is made with ice. Everything that we build, whether it is a brick and mortar product, or a consumer commodity, or a software application, there is a purpose. Do you remember buying anything ever that did not serve any purpose? Purpose is the primary driver for any kind of product creation or development. So that's why we build software that supports payroll or a banking teller or helps to fly an aircraft through autopilot mechanism or even a game. Because there is a huge bunch of people who love to play to spend their pastime. Once we are convinced about the purpose the product shall fulfill, we look for features. One or more features help the product to achieve the purpose. We buy a car, the purpose is transportation in a private vehicle. Then there are some features that are essential or important in nature. For example, airbags, anti-braking systems. And then there are some features which are nice to have. For example, car entertainment systems. You very well know features of different software applications. For example, a navigation bar. Navigation bars exist to go to different areas of an application. Some applications provide shortcut hotkeys to do the same thing. These are functional needs, which may fall under the categories must have, should have, could have, or nice to have. After purpose and functional needs comes the quality needs. We want our food to be fresh. We want our face cream to be of good quality. We want our new shirt to be looking nice on me, which also means quality can be subjective. Some qualities can be mandatory, like fresh food. When we build any product, there may be some concerns too that we need to address. Will this shirt be good enough to protect me in winter? Will this face cream be okay with my oily skin? I don't want my software to crash when the user inputs some wrong data. Or the web page should load reasonably fast, maybe in 3 to 5 seconds, despite having 1 million concurrent users. Despite focusing on a very useful purpose, fulfilling a great deal of functional needs or features, a product may be a disaster if the concerns are not taken care of. They are as important as quality. Often, quality and concern are used interchangeably, though they are not necessarily the same thing. And then come constraints. Every product is built under some constraints. Let's say if I'm starting a fashion brand, I might decide to focus on a smaller market, maybe just my country, because otherwise I may have to dish out a large sum of investment. Here, money is the constraint. Because we stay in the upper region of Himalayas, our houses can only be built using wood. That is not only cost effective for material and transportation, but also provides an additional layer of thermal insulation. The customer says, this software must go live by end of the next quarter, else our competitor may release their product and thus grab the market. All products are built under such constraints. All these are primary drivers of developing any product, including software, of course. Each of these drivers are meant to satisfy the customers because these drivers came from them mostly. These are all mandatory inputs to an architect. These inputs combined is the requirement. If any of these drivers are missing, the architect has to go back and ask the customer about them. But those drivers are primary inputs. The next set of inputs come from his own knowledge, his wisdom, his experience. They come in the form of design principles and best practices. A lot of these are or can be documented. Mostly, these are common sense that arise out of experience. With these primary and secondary inputs in place, the architect is now ready to work out a technical solution to address the problem, the requirement. And finally, he comes out with the high-level solution design. Drivers, architects, designs, where goes the architecture? Let's wait for a few more moments before we get to that answer. As we can see, the architect analyzes the drivers, exercises synthesis to convert the drivers to solution designs. To be able to do that, he follows architectural process, applies architectural judgments, uses meta models, patterns, principles, decide on architectural styles and views. In later part of this series, we shall go through most of this. So don't worry if you do not understand fully. Just a mental guess would be fine. Most of this exercise is towards deriving strategy, proposing a structure, fulfilling a purpose. All or most of it is still abstract in nature. It's like saying, for this product, we shall use a cloud infrastructure for ingesting all data and shall show to the dashboard through both code and hot path. Pretty abstract, right? Once again, ignore cold path and hot path if you don't know what they mean. You will learn when we get there. The design he comes up with is focused on implementation, on best practices, on documenting the ideas. It is more concrete in nature for the stakeholders to understand, for the engineers to follow. And all of it together is architecture. So it's not a single act that you can call an architecture. It's not a single piece of document that you can call an architecture. It's a process, it's a communication, it's a document, it's the thoughts, it's those ideas, it's the solution. Everything together is architecture. A piece of architecture therefore serves a purpose, provides tangible functionalities, fulfills quality needs, addresses important concerns, takes measures against those constraints, and then applies process, principles, best practices, etc. to deliver a design that is tangible in nature and ready to be implemented. That is how requirements are related to architecture and why requirements are critical inputs for any architect. Next, coming up, types of requirements. Please do subscribe, like, share if you are benefiting from these sessions. Thank you.